Now, today we're thrilled to introduce David New. He's the founder and entrepreneurial force behind a company called Obaggo. And this webinar is entitled The Plastic Bag Recycling, the Obaggo Story. Dave founded the company about 10 years ago. He has an MBA in operations management from Cornell and a BS in computer science from the University of Vermont. He has 35 years of experience in logistics systems design and implementation, supply chain consulting to companies like Mastercraft Boats, Thermo Fisher Scientific, Zippo, and dozens more. As a lifelong environmentalist and recycler, Dave was frustrated by his forgetfulness and his inability to properly recycle plastic bags at retail store bins. The idea of two separate supply chains for recycling, an inconvenient one for plastic bags and the convenient one via curbside for everything else, just doesn't seem optimal. Therefore, Obaggo was born. And when not transforming polyethylene bags into pucks, Dave is often outdoors, climbing a mountain or hiking a trail. Now, let's give a big welcome to David. I'll hand it over to you.
Thanks so much, Carl and Connor. Appreciate it. Yeah, so thank you for that great intro. I'm going to keep this a little bit lighter than maybe the typical webinar for polymer scientists. This is really the story, the entrepreneurial story of a startup, and hopefully it'll be a little entertaining and informative. So without further ado, I will figure out how to advance my screen here. There we go. So meet our heroes. I'm Plastic Man, Dave New, and this is my trusty sidekick, Plastic Girl, also known as Vicky Ferry, my fiance, and she's been helping me save the world one plastic bag at a time. Connor started out by telling you a little bit about the origins of this, but I'm going to back it up a little bit more. My environmentalism started back in the 1970s. I grew up in New Jersey in the shadow of the Meadowlands, which at the time were being used as landfill for New York City. And back then, my father was a concerned resident, and he knew that we couldn't just keep generating waste and piling it up forever, that at some point, we were going to have to figure a way to reduce the amount of materials we sent to landfill. So he got together with some other concerned residents and created one of the country's first recycling centers in Montclair, New Jersey. And so I grew up in that recycling family, helping out on the weekends, unloading cars, sorting magazines from newspapers and brown, green, and clear glass, and so forth. And so, so I grew up trying to, recycle as much as I could. When I became an adult, for some reason, I just could not seem to do what I was supposed to do especially when it came to plastic bags. As Connor mentioned in his opening remarks, I'd get to the grocery store and I'd read this sign, and I would just go, duh, they're at home, or I'd be in the checkout line and I remember the bags are in my trunk, or the reusable bags just could never seem to get back to the grocery store. And I thought, well, maybe other people are having the same problem. And of course, there are reminders everywhere. You see bags in the environment. I went to Costa Rica. I saw this monkey with a bag, and it really, took away from the experience. So, so I asked myself, what is the difference between these bags, which we can't recycle, and something like a milk jug, which we can? And of course, we're all familiar with those chasing arrows symbols. I didn't really know what they meant, what the numbers meant, or what the lettering meant. But fortunately, I had Google, and I did a little research, and I found out that, well, bags are bad shape, and they jam up the material handling equipment at the material recovery facilities where recyclables are taken. And they also contaminate the fiber stream, the paper, and so forth. So so that was the eye opener for me. And I guess I got that glimmer of idea in the back of my head. You know, what if the bags just weren't the shape of the bag? Would they be recyclable? And, you know, I guess every good idea has its seminal moment. And here I was watching Monday Night Football with a friend who happened to be an engineer. And I just, maybe after one beer too many, mentioned this idea to him. And he walks into a closet, gets an iron out. And 5 minutes later, sure enough, we had thermoformed our first plastic bag. And I knew it was possible. So, you know, doing a little bit more Googling, I found out that Trex actually uses plastic bags to make its products, and they're very good products. So that was a real fortuitous find, because I had an old roommate who was a VP of marketing for Trex, and he put me in touch with a guy named Dave Heglis, who ran their recycling plant down in Winchester, Virginia, and was very kind and gave me a complete education on the plastic bag recycling industry, and all about how the Trex retail collection system works. Trex helps the supermarkets put the bins at the front of the store, where at the end of the day, the bags are put on trucks, the same delivery trucks that go back to their distribution centers. And then Trex sends tractor trailers along a number of routes on the East Coast and the West Coast, stopping off at the supermarket distribution centers, picking up those bales of bags, and then taking them back to their facilities where they're eventually turned into decking. So that was really a great education. And for some reason, that just became my call to adventure. And that's kind of where I left the ordinary world and went into the magical world of entrepreneurship. And I didn't really leave my 9-to-5 job. No entrepreneur really should, until you start getting revenues. But as any budding inventor would probably do, I looked for an existing solution. Thought maybe the Presto burger might be something that would work. So I ordered one on Amazon, and I put plastic bags in. Very quickly found out that the Presto burger doesn't heat on both sides. How do you cook a hamburger when it all heats on one side? I don't know, but it doesn't. So I actually ordered another Presto burger, and I cut them apart, and I built them into, voila, the first Obaggo, called the Obaggo 1. And I fiberglassed a little enclosure, looks like a coffin, and I cut some wood out, and I chopped apart the Presto burger device, and I started my experimenting. And I created 101 different melted pieces of plastic bag. Thought, well, maybe we could make your plastic bags into crafts. Maybe you could melt them down into little coins. So it was a good learning experience, my first invention. And probably the most important lesson was, don't build a heating appliance out of wood. So actually my second version of the prototype was out of aluminum. I found a local machine shop who was willing to assemble a little oven for me. And I knew this one wouldn't catch on fire, at least. But the only problem I had with this was it didn't have any kind of temperature control or timer. I left it plugged in once over Thanksgiving weekend. I came back and it had shattered my granite countertop in my kitchen. Spider cracks going in every direction from this thing. The Christmas timer had accidentally turned itself on while I was gone. So after getting a cease and desist letter from my apartment complex and paying for a new granite countertop, I expanded on my experimentation at a different location. And so of course, the big variables I had to solve were, how much time do you melt the bags, and at what temperature, and how much pressure, and what shape should you make them in, and what size should it be? What's the optimal size for a puck of bags? So I built a much more complicated device that let me do this experimenting. And I varied all of those different variables and zeroed in on exactly what I wanted. And finally got what I thought was just the perfect thermoformed puck. And one of the concerns was whether or not this was going to be safe. So this was kind of my showstopper issue at the time was, here I am melting plastic in my kitchen. Can we do it safely? So we actually made a separate device that I gave to an indoor air quality laboratory. And it was designed so you could operate it from outside of a hood and do the experiment inside the hood. And we actually proved that you could thermoform bags safely if you control the temperature properly. So that was a real great moment for proving the concept. The problem with that device was it didn't show well. I brought that around to investors. I found groups of local investors. There's like Beacon Hill investors and a number of others. And something about this device just wasn't really sexy to them. It just conceptually did not, they couldn't make that conceptual leap. So I thought, well, I'm going to have to make this look like something that would sit on your kitchen countertop. And I thought, well, the biggest appliance that I would want is something as big as my coffee maker. So I talked to some people at Mastercraft Boats who were really great at building boats, and they said, well, why don't you fiberglass it? They taught me how to create a foam core and then fiberglass it, and out of that, the Obaggo 3 was born. And I worked with my local machine shop, got parts to fit inside. And I thought, wow, this is fantastic. Now I've got it. I can go out and sell this thing and convince people to fund this project. So I built a lot of pucks. I actually had pucks made with business cards on them. I brought that device to plastic recycling conventions, and I handed out pucks to people explaining what I was doing. And it still kind of went over like a lead balloon. You're like, why are you doing this? A couple of people thought it was a neat idea, but and I realized that that device just wasn't sexy enough. It wasn't what people wanted to see. So back to the drawing board, hired an engineer, and we started a skunk works where we tried to create a much cleverer device, and we ended up with what is very close to what we're going to market with now, which is a very sleek, automated, nice looking device for your kitchen countertop. And I don't really call it the Obaggo 4, but it's probably like the 5, 6, 7, or 8. But it's quite a journey to go through all these different prototypes. That particular device, we were concerned about the cost because it just has so much electronics and so much material. We thought, well, we really need to explore this. It should just be simple. The plastic bag is simple. Recycling it should be simple. We want just a simple lever and a spring device. And so we hired another group of engineers to explore all the different ways which you could use mechanical advantage to compress plastic film while you're thermoforming it. And the whole array of prototypes. Actually, after that experiment, we really came back to what we had, something very similar to what we had before. We realized that we could actually make the Obaggo automated device at a reasonable cost if it had design for manufacturability phase. So, so this is actually the product which we intend to go to market with. So once I had that, it was time to really find out, how is this going to be accepted by the industry? Okay. How are plastic bags recycled? Will they recycle the way regular grocery store retail bags are? So I brought the bags to the pucks to a company up in Ipswich called North America, and they sell industrial shredding machines. And we did a test where we put loose plastic bags in and we put Obaggo pucks in, and voila, they shredded up almost identically. And we got very fortunate also up in Ipswich. A gentleman by the name of Martin Bauman invited us up to do a test on their plastic extrusion equipment. And this was terrific for telling a really important part of the story for folks, which is, how plastic bags are recycled. They're taken, they're collected, they're ground up, they're washed and dried, they're put through an extrusion machine, and they're turned back into pellets, which can then be made into new products. We also went out and toured some of the local area material recovery facilities like E.L. Harvey down in Westboro, Casella in Charlestown, and JRM up in Peabody. And I actually took some pucks and was able to do a sorting test at a material recovery facility up in, I think it's in North Andover. And that test worked fine, that the pucks sorted to where they were supposed to go. So I had been pretty successful in proving that the pucks do have a good chance of being recyclable into good products, but there were still all these lingering issues, such as, will people buy it? And if so, what price will they pay, and can I achieve that cost? And will the stakeholders accept the idea of a puck, or will material recovery facilities sort the pucks out? And did we get the shape right and the size? And what is the optimal shape and size of a sortable puck? And then the indoor air quality issues. We did do that initial test, but the final prototype hadn't been tested yet. And what will people do? Will they use it properly? Will they put the wrong things in? And how do we deal with contaminants? I was speaking to one group at Dassault Systems. I think it was speaking at an innovation presentation, and during the Q&A session, a guy said, "What if I take my kids' Ziploc bags from their peanut butter and jelly sandwiches and put it in?" And I told him that he was my biggest nightmare, because nobody wants peanut butter and jelly in their post-consumer recycled resin. And what if people put in chip bags, which has foil and it's not recyclable, or protein stained meat packaging? And so all these things were concerns of mine. And so I spent a lot of time trying to find out how big an issue those things were. Are they showstopper issues? We have this trend towards different types of plastic bags that might be more sustainable, more environmentally correct. And maybe some of you folks are working on these types of things. They're very confusing to the end consumer. Things like this bag, which says it's both recyclable and biodegradable. So, hidden on a side panel is the #2 high density polyethylene, which, as we know, isn't really particularly biodegradable. And this represents a contaminant for the recycling chain. Not a lot of purchasers of post-consumer resin want biodegradability in their raw material. So how do we deal with all that? the issue came down to what is really happening right now with the retail store bags. They're getting all those types of things. They're getting Ziploc bags with peanut butter. They're getting some chip bags. They're getting the wrong types of unrecyclable film. And they have roughly, they have ways of dealing with it up to a certain level. And so our goal was to make sure that we're providing a similar product to the supply chain as the retail bags. And our pucks are designed to not be melted all the way through. So they are actually kind of thermoformed, they're encapsulated, and then there's a lot of loose layers inside. And what that allows, when you shred them, they shred up just like loose bags. You can remove contaminants. You can sort them. You can do float sink sorting. You can, the ARIMA machine has something called a laser filter, which sorts out contaminants that don't melt at the temperature you're shooting for. And this encapsulation it keeps the film clean through the whole supply chain. So all these layers of surface area are just as clean when they reach the recycler as they are in your kitchen. So we really felt like, people are going to follow instructions to the same level, at least, as the retail store, and the material is going to be as clean and dry, at least, as the retail store. So, I think we really have something. It's not really, contamination should not be a showstopper issue. Plus, we have a lot of things that are really working in our advantage. Like we really have consumer awareness of sustainability and packaging is improving. It's an increasing trend. There's an increasing trend to sustainable packaging. You may work for companies that are creating alternatives to the multi-layer pouches that are currently not recyclable. Dow has their recycle-ready packaging. The labeling is improving. And the labeling is terrible for film for some reason, but it's getting better. And they're adopting new standards, and it's getting on more product. And so over time, I can see where the consumer will do a better and better job. The downstream, the imaging and sorting technology is improving, and compatibilizers and stabilizers are being developed by the petrochemical companies, and Exxon has their Vistamax line of product, and BASF and BP and Shell, and there are all these different products which now help different plastics blend together into a homogeneous material that can then be used to make it into good products. We also are watching recycling infrastructure build out because of, I'd say a lot of it is because of the Chinese national sword policy. We now have to deal with a lot more of our waste domestically, our recyclables, I should say. And so we're seeing a build out of both mechanical and chemical recycling plants all over the country. And they have a voracious need for raw materials. So, so all these things, including, increase of the end market for post-consumer resin, are working in our favor. And so it's against this backdrop that we see a market for our product. And of course, at the end of the day, if we don't divert the material in the kitchen into the recycling stream, it goes in the garbage can. And once it goes to landfill or to incineration, it's a resource that can never be recovered again. So if we're diverting it, at least there's a chance to recover it into something useful. And so that's really what's driving us right now. So pretty certain that we have a product and that there's a need, and but it takes a lot of money to get a product to market, especially a hardware item that it's got a lot of custom parts, and it needs to be manufactured at a low cost. So we set out looking for money. And of course, everybody suggests, why don't you go on Shark Tank? This is a great idea. And I I sometimes feel like if I had $1 for every time somebody said that to me, I could be commercialized by now. But we went the traditional route. I made the rounds to the plastic industry, thinking first they should be most interested in another solution for plastic film recycling. Of course, the American Chemistry Council has the Flexible Film Recycling Group. We meet a lot of great people at the Association of Plastic Recyclers. They have a flexible film recycling committee. I went to their conventions in 2018 and 19, and of course in 2020 it was canceled. And made a lot of great contacts there, but came back dry as far as funding. What's available to a lot of people, and probably some of you folks who have invention ideas, small business innovation research grants are a great option. For some reason, Obaggo did not fall within the parameters they set. You have to be high technical risk in order to get an SBIR grant. And I already had a working prototype, so no technical risk there. And I was told it lacked intellectual merit, which I kind of took offense to, but so SBIR wasn't an option for me. And then I looked to the Mass Clean Energy Center, which provides a lot of grant funding for piloting and clean energy technology. But recycling right now isn't really considered, doesn't really fall into clean energy. There are some energy savings of mechanical recycling over virgin plastic creation, but it's not really considered clean technology, clean energy. The closed loop fund, which actually there are 3 groups: closed loop fund, closed loop partners, closed loop ventures. For some reason, Obaggo wasn't a great fit for either of those. The fund actually provides capitalized loans for purchase of capital equipment. I should say collateralized loans. Closed Loop Ventures is a venture capital group, and I didn't fit their investment philosophy. And Closed Loop Partners was for 501c3, or I might have said that wrong, for not for profits. And so I was striking out a number of different places. I had a small win with the Alliance to End Plastic Waste. So you're probably familiar with this group. You may work for one of these companies. The Alliance to End Plastic Waste was a fund that was created initially with $1.5 billion from the member companies to try to reduce or end plastic waste. And the way that they were going to try to find the innovations to support was they ran a kind of a contest to find companies for their first round of innovators. They were looking for 10 companies to support. And I put in my application along with 600 other companies. And luckily I actually made the final 20. And I was invited to come out from Boston to fly out to Sunnyvale, California, and give a 4-minute pitch with 2 minutes of Q&A to see if I could get in, make the final 10. So, I didn't have a lot of money. I didn't have a lot of time, but I thought, well, maybe this is how business is done. Of course, this was pre-COVID. It was in January of 2020. And I thought, oh, what the heck? I flew out to California and I gave my 4-minute song and dance and threw pucks at the crowd. And somehow at the end of the day, I made the final 10. And I was in the first cohort of innovators in the Alliance to End Plastic Waste program. And through that program, it was great. I met the sustainability folks from a lot of these companies and pitched to them. But but I did not walk away with an investment. And I came to realize that the reason for this was really primarily that there's the kind of a feeling in the industry that the bag and film problem from a consumer recycling standpoint has kind of been solved. Hey, we got the retail store take back program. Most people in the country can find one of these bins at their supermarket. So it's kind of like problem solved. It was more like I'm a solution in search of a problem. But I think I know, and probably a lot of you folks know that we're only capturing about low single-digit percentages of bags. And we know that recycling in general, we can capture 50, 60, 70% of other packaging. So this problem is definitely not solved. But I did, you have to keep on going. Don't take no for an answer, just keep looking. So I had to learn how to pitch. Also, I'd like to say, learn how to do the hustle, get out there and try to entice as many people as you can to hear your story. Boston is a great city for being an innovator. There are lots of opportunities to pitch. You just have to have a lot of different pitches. If you want to have a startup in Boston, you're going to need an elevator pitch, a 1-minute pitch, 99-second pitch, 2-minute pitch, 4-minute pitch, 10-minute pitch, 20. Everybody wants a different pitch, and so as an introvert, and someone who's I was not really accustomed to public speaking. It was hard for me, but you learn it, you get used to it, and you have fun with it. And so we did this. We got out there. We presented in every opportunity at conferences, at conventions. Sometimes this was at the Boston Green Fest. We were in the basement of the Marriott Long Wharf, not a high traffic area, let me tell you. At the Natick Earth Day, we were in the nursery school in the basement of an elementary school. And actually a lot of traffic down there. And we were the official plastic bag recyclers for the head of the Charles Regatta, and spoke at the New York State Association of Recyclers, and pitched, at the Boston Convention Center, at Horizon 19, and a whole bunch of other things. And it's a lot of fun. You get out there, you talk to customers, you talk to stakeholders, you talk to just interested people, and you got to do that. It's the only way you can keep validating your business. And another big step, anybody who's thinking about starting a company, seriously consider these accelerator programs. They're out there to help you. We joined the Clean Tech Open in 2018, which is a clean technologies accelerator. It's a national competition. They assign you mentors, and they take you through a process of creating, I forget the word for it, like a business roadmap, a business plan, financial plan, go-to-market strategy, and you create a pitch deck, and you pitch that to judges, and in the end can end up with prize money. Excuse me. And actually, the Alliance to End Plastic Waste was an accelerator run by Plug and Play. I was in their first sustainability cohort of 10 companies. In 2020, through the pandemic, I was in the Mass Challenge, and that was a great experience. I made it to, not the final round, the pre-final round of judging. And my problem there was right as I was about to, I thought I was about to make the finals. I think it was National Public Radio came out with a story about how plastic recycling has always been a big hoax. And that really soured the judges. on plastic recycling. So these things were all great experiences. I highly recommend Accelerators. Through the New England Innovation Awards, I got some great media attention. I was on CBS Boston, a local story, but I got tremendous attention to my website. And from that, I got a Boston.com article, hamming it up a little bit here in the photo. But all these things build on each other and you can start to get traction. One of the best things was Cheddar saw me on television and they just said, do you mind if we just create a Cheddar about you? And I got a lot of, I think I'm still getting traffic from that. And I think there's going to be a Boston Globe article sometime in the near future. So that really brings us all the way up to where I am today. It looks like the consumer is really excited about this, and they're hopefully going to be the ones that back this. You may be familiar with Kickstarter, Indiegogo, GoFundMe. There are a lot of different crowdfunding sites. When you're trying to fund a product, it's not a game really for the little guys anymore. Kickstarter, crowdfunding, it's a science, and the big companies are playing it. They are, companies like Bose might spend $1 million on a Kickstarter. You probably wouldn't know that it's Bose, but they're using this to test market a new product. And so you're competing against companies with big bucks, can produce highly polished videos and put lots of money into their campaigns. There's a real numbers game. You have to bring to crowdfunding most of your backers. You don't just build a campaign and they will come, the backers will come. It doesn't work that way. You have to bring most of your own backers. So that means creating a lot of ads and advertising and getting your own, finding your own supporters. And for that, we actually created a video. I'm going to show you a little video now that we are currently running right now on like Facebook ads and so forth. And I'll play it.
Hi, my name is Dave New. I'm the founder of Obaggo Recycling. Obaggo is a startup focused on solving the plastic bag and packaging film recycling problem. In the US alone, we get over 380 billion pieces of plastic bags and packaging film. Plastic film is the fastest growing type of plastic packaging, growing at 6% a year. It's growing at 6% a year because it's so cheap. It's made out of ethane, a byproduct of fracking, which is easily turned into ethylene and then polyethylene. When they get to the material recovery facilities where recyclables are taken, they tend to jam up the equipment, causing costly shutdowns, and expensive day laborers have to pull the bags off the belt. And because of this, they're banned from almost all curbside programs. Everybody who touches bags in the recycling chain tends to lose money. They're very thin, light, and not a lot of material, and handling them costs more than you get when you recover the material. So what we need is for the consumer to take on a little effort, a little cost, and transform the economics of recycling the plastic. If we all do a little bit in our home to turn the bags into a dense piece of plastic, it becomes profitable for everybody downstream to collect it and recover it. You take the material, crush it all together, put it in the device, and with push of a button, in 15 minutes, and for less cost than making a piece of toast, you've transformed your unrecyclable plastic bags into a recyclable disc, which you can now toss into your curbside bin with your other recyclables. This plastic is a resource, and we're wasting it. It's either going to landfill, where it's going to disappear forever, or it's polluting our environment. You need to divert this into the recycling stream in your kitchen. You'll be making a huge difference in the world, one bag at a time.
So making videos is it's a lot of fun. It's a lot of hard work, but that's really the best way to communicate kind of a complicated story of why densifying plastic bags into a disc is something you'd want to do in your kitchen. So hopefully we will find all those people that can back our crowdfunding campaign and be able to drive them to that campaign once it launches. So that brings us pretty much up to present day. For all of you budding inventors out there, I'll just share a couple lessons learned. Probably the first and the most important thing is, when you have an idea for a product, just be aware that you're going to spend most of your time between when you get that idea and when you get to market in the trough of sorrow. There's a lot of excitement when you first get the idea and as you move it forward. And then there's the long, slow slog through all the inevitable things that you're going to have to go through, prototype development and proof of concept and finding investors and so forth. So be prepared for that. One of the things that really kept me going through the whole process is something that I heard paraphrased from Thomas Edison. His invention of the light bulb. It took 10,000 different tries before he got the light bulb to work. I heard it paraphrased that Edison said, I didn't fail 9,999 times. Creating the light bulb was a 10,000 step process. And I like that paraphrasing better. Changing the world really is always going to be a 10,000 step process. And I don't know which step I'm on right now, but we're working to change the world and we're just trying to do it one step at a time. And similar thing that helps me is this quote by Admiral William H. McRaven, who in one of his graduation speeches says, if you want to change the world, start off by making your bed. Now that's a really good one, both literally as well as figuratively. And so I would recommend, like the steps, complete small steps that you can do one at a time, and you'll eventually get there. And of course, if you have an idea and you want to go out there and change the world, of course, please just go out there and just do it. So that's all I have for you, and I'm happy to take your questions now. Thank you so much for the opportunity.
Excellent, David. Thanks a million. That was great from start to end. A great story. Bring it all the way back up to present time. So we did get a few questions. I tried to answer some of them online based on having seen a little bit of this before, but let's just go to the top here. So the question is, how does the current system handle contamination in film? And I'm going to assume that the system in question is today's recycling system. So how does it handle contamination with film?
Sure. So I think just about every film reprocessor has their own technique for dealing with contamination. Contamination to one film reprocessor is not contamination to another. So a lot of it comes down to what is the end market that the reprocessor uses the PCR, the resin, who are they selling to and what are they using it for? And that often drives what they're going to have to do upstream. So if the resin is going to be used to make railroad ties, then contamination is a lot less of an issue. You're making railroad ties. Who cares if it's dirty? Who cares if it has peanut butter and jelly in it, I guess. But if you're going to use it as a component, 25% PCR of recycled garbage bags, well, it's got to be able to be blow molded into a garbage bag, so it's got to be much better. So the upstream process will be suited to achieve that goal. So some reprocessors will shred the bags. They'll do a they might wash them first and then do a float sink sort on the flake. It might go through a centrifuge to do another type of sort. That might then go through a sort through, when it's in the extruder, go through like a laser filter, I think is what ARIMA calls it. And so they might add compatibilizers and stabilizers to help polypropylene blend with polyethylenes. And so they may or they may not do any one of those different things, or they may have other things they do. There's a film reclaimer called EFS. They have locations in Toronto and Pennsylvania, and they don't talk about what they do. It's like a black box, and but they use a lot of film, and they produce a high quality resin which they sell to their customers.
So the question about contamination, then, both in like the recycling systems, but there's also been a few questions here about let's say the consumer by putting in like in PVC, for example, right? The system will still melt it and make it into a puck. It really it depends what happens afterwards, right?
Right.
I mean, the puck won't not be accepted because there's PVC in there, or how would the curbside recycler, how would they know?
Yeah, so with recyclables, the contamination doesn't really become a problem until you get to the reprocessor. The retail store take back program gets all kinds of stuff in those bins. People throw out their beverage bottles and their cups, and I reach into those bins because that's where I get a lot of my bags from, the supermarket, and it's filthy. It's covered in Coca-Cola. It's sticky. There's people put their napkins and that a lot of that stuff gets baled up as an entire bag, and it then gets turned into a big cube with a whole bunch of other bags, and then those bales get to the reprocessor, and they don't have time to pick through all that stuff. So it's getting processed with a lot of that waste. And so beyond a certain level, contamination can destroy the ability to recover the plastic from it. But within certain levels, they have already figured out ways to deal with it. And because of that, I'm very encouraged that we can educate the consumer and keep the mistakes, the contamination down to a minimum. And then the downstream process should be able to deal with it. And so that's the theory, and that's what we're going with.
Right. So there's a lot of sort of similar questions on that theme then, and it comes down to some type of consumer education. Are you going to explain to the consumers, what types of bags can be put in?
Sure.
Somebody noticed there was an Amazon package in there, and they typically have paper labels. Do those have to be taken off, for example?
Absolutely. So the instructions will be, no paper labels. What happens with a paper label when it goes through a plastic extruder, at 270 degrees Fahrenheit, it burns, and it makes the PCR smelly. It smells like, burnt wood, and that limits the downstream application of the material. So yeah, the fewer contaminants, the better. We're hoping for an Amazon shipping envelope that's been printed on with ink, and I believe that Amcor or Berry Global, they already make a shipping envelope system where you can print right onto the shipping envelope, so you don't have to have a piece of paper. And that was all designed with sustainability in mind. And so, so the trends in sustainable packaging, I hope, will eventually catch up with us and help create a cleaner stream of film. But yeah, things are unknown exactly what we will experience when we hit the market.
So this is the Society of Plastics Engineers, remember, right? So there's some technical questions. Let's see if you're if you're up to it. Well, so I'll try to combine a few of these things then into some of the technical aspects of how the machine works in terms of like the amount of heat that's going into these. Is it enough to affect the heat history of the polymer? And then also related to like the energy used for the recycling there, did you do any type of LCA, or is it possible to do an LCA on this type of, it's not exactly recycling, but versus the use of virgin PE? I mean, I will also just preempt it a little bit by saying there are LCAs out there already on that, but have you spoken to anybody about LCAs?
Yeah, absolutely. So the first question is about the amount of heat and energy that we apply. And I couldn't answer with any authority how much we're like damaging the film from the heat that we apply. Certainly the outer layer will get a certain degree of melting because it's in direct contact with the heating elements, the heating plates. But the inner layers are really just encapsulated. So while there may be some thermal degradation to the outside, most of the inside is really not heating up that much. Plastic film, hundreds of layers are really, there's air in there. It's quite a good insulator. So the center material is not going to be damaged too much from the heat. The issue of life cycle analysis, when I was in the Clean Tech Open, one of the service providers allowed us to use a life cycle analysis tool. And when I put in the parameters that I expected for this device, which is the carbon footprint of creating the device out of the expected materials you expect to use, plus the energy consumed for each cycle of the device over the life of the device. And you have to say, well, how long is the device going to be used? 10 years, 20 years, how many times per year? And what is the energy value of the recovered material? And all these numbers are available. The EPA has a tool called the WARM tool, which can be used for life cycle assessment and figuring out the carbon offset of recycling versus landfilling versus incineration and so forth. And so we figured that the use of our device is about 5% or less of the energy cost or carbon footprint of the disposal of the material. So, so it's hard to think of what does 5% mean, but but it's a fairly, I think it's a fairly compelling argument for doing this. It's not like we're using so much energy that it just doesn't make any sense. Right. Of course, I have solar panels on my house, so there's no carbon footprint to me thermoforming pucks in my kitchen.
So speaking of the pucks themselves, so what are the dimensions and weight of each puck? Is it consistent? Is it the same every time?
No, it's not. And so it'll depend on the user. The pucks are anywhere between, let's say, 3 ounces and 8 ounces. That's actually a sweet spot for recycling. We don't want it to be bigger than 8 ounces because a lot of material recovery facilities use an optical sort with a pneumatic air jet to redirect material into different stream. And so those pneumatic air nozzles can't redirect very consistently heavy objects. So you don't want it to be too heavy. You also don't want it to be too light and thin, because if it lays too flat, it won't look three-dimensional, and it will travel with cardboard and paper to the fiber stream. And they don't want that to happen. So we have to keep it relatively light, three-dimensional, and hopefully with polyethylene on the outside so that an optical scan can detect it as polyethylene. And we don't want it to look like PET, because that could then contaminate the water bottle stream, which is one of the most profitable commodities that a material recovery facility recycles. And we don't want it to look like a natural colored HDPE milk jug, because that's, you know, one of like the second most profitable
Right.
Plastic commodity.
So you and I talked a little bit about the JP Mascaro project that was done by MRFF. Do you think that updated MRF model of being able to recover flexible on a large, do you think that will be scalable?
I think it's going to be a long time before that's scalable. So for those who aren't familiar, the Material Recovery for the Future project is trying to pilot test a material recovery facility that can accept loose film in the curbside bin, commingled with all the other items. And so right now, that to do this, it requires about a $3 million capital investment for the material recovery facility. And it changes the economics of their process. And it actually will, they've got it pretty well fine-tuned so that it, the plastic film does not get into the fiber stream, which was always the biggest concern, was that you would get pouches and bags and other types of wrapping in with the fiber, and that would reduce the value, because nobody who runs a pulp mill wants to have a lot of plastic in with the paper. So they were able to successfully get that down very low. However, it turns out that the film has a lot of fiber in it. And so you end up with a lot of this film and a lot of its pouches and bags and wrappings, but the film has a lot of fiber in it. So you end up with this commodity that has a fairly low value. And if you think about the surface areas of bags and film, they end up getting very dirty. And so you get a lot of dirty mixed film out of this, which has very low value. It has to be washed and dried. It has to be sorted out, and that's definite added cost. And so the material recovery for the future may work someday, but right now the economics are that you spend a lot of money, you get a low value commodity out, and it just doesn't work.
That seems a bit part. So we're almost out of time, but I saved the most important question to the end. Give you enough time. How much does it cost, and when and where can people buy them?
Sure. Well, we are shooting for $149 price point. The device is not so simple. It's got a lot of custom parts, and it's going to take a lot of custom tooling. But we think we can do it for that sales price. And we're hoping to have that available for pre-sale on our crowdfunding campaign, I'd say within about 5 to 6 weeks. And then the actual devices would ship within, I'd have to revisit the project plan, but within 6 months or so of the completion of that crowdfunding campaign, we should be able to ship units. So, with any luck, early next year. I don't think in time for Christmas, sadly, but early next year, we hope to be shipping product.
Awesome. All right, Dave, well, we're just, there's still a few questions left on here. We try to consolidate them, but in the interest of time, we'll wrap it up. I would encourage everybody to get in touch with David, either through LinkedIn or on his website for some of these other questions. If anybody is interested in reading a summary of the MRFF report, I do have a copy as well. You can certainly direct message me. I can send you that PDF copy. So with that, we'll sign off. Everybody will get a copy and a link afterwards. David, thanks a million. Keep up the strength, keep up the perspiration, the inspiration, the effort, everything else you need. And hopefully we'll all have one of these on our unbroken granite kitchen countertops early next year.
Yeah, thank you so much, Connor. And thank you everybody for your time today. And yeah, please subscribe on our website, and we'll let you know. We'll make sure that you know when our crowdfunding campaign launches.
Fantastic. All right, David. Thanks a lot. Thanks, everybody. Have a good day.
Everybody have a good day. Bye.
Bye.